Hi dosto, in the series of dynamic programming, today we are going to start our second class template question. So before that, I want to tell you that we have already completed our class 1. So in the class 1, if you want to solve more questions based on 0-1 knapsack, then link to those questions is there in the description. अच्छा, so अपना motive यही है कि कम मेहनत में ज़्यादा marks. So we want to do less work, or I should say we want to do the smart work, and you are going to get all the questions in a structured way, so that you don't have to go and struggle here and there. So in every class we are going to solve one simple template question. Now once you solve that template question, then we are going to solve more questions based on that template questions, that how all those questions are just related to that particular template question. Okay, so let's start our journey without wasting time. So the template question is minimum number of coins. Now problem description. Given a value v, if we want to make change for v cents and we have infinite supply of each of c, that's your denomination c1, c2, cm valued coins, then what is the minimum number of coins to make the change? Okay. Now that's pretty simple. So basically you went to a shopkeeper, you gave them, let's say, some 500 and you want changes. Now the shopkeeper wants to give you the minimum number of coins. So what all denomination he should choose from the denominations that he have, so that he has to give minimum number of coins. Okay? So let's take an example. Suppose the shopkeeper has coins 1, 3 and 5, and you want a change of, let's say, 7 rupees. So now in order to give the change for 7, the shopkeeper can give you 5 or plus 1, or he can give 3 plus 1. Well, in any case scenario, it will be 3 coins. Okay. So that's what the question says, and you have to find minimum number of such coins. Okay, cool. Let's go ahead. So the very first step that we follow is to draw our recursion diagram. So we read the question and then we try to make a recursion diagram. Okay? अभी भी वही करेंगे. So what does the question says? Let's read it again. That what is the minimum number of coins to make the change? So that means basically the change that you want. I mean, if I ask you, if you are the shopkeeper and someone asks you for a change of 200, so will you give him a change of, like, will you give him a coin of 500 or something? I mean, nahi, बहुत stupid है sound करने में, but obviously nahi, because like this is a very logical thing that if someone asks a change for, let's say, 200, then you need to make sure that the coin shouldn't be greater than 200. Okay? So that will be a very first condition. We'll say if this is the denomination of coins that you have, okay, if A represents that, and right now we are talking about this denomination, then the very first condition is that your A of I is less than equal to, let's say, well, so value is the change that you want to find. Now if this condition is false, so let's say you want someone asks you for a change of, instead of B we'll write well. Okay, so someone asks you a change of, let's say, 10 and you have a denomination of 15. So definitely you cannot take that denomination. So what you will do, you will just simply move to the next denomination. So we'll go to I minus 1. So basically we'll go to the next denomination, or in this case we'll just move to the next, or simply say we will not include, or we will not include this in our answer. ठीक है, like answer का जो coin बना रहे ना minimum number of coins का, वो अपन नहीं करेंगे. ठीक है. Now the next possibility is that what if this condition is true? Now if this condition is true, then they're asking for minimum number of coins. अच्छा. So you may give a denomination of this coin or you may not. So now you might be thinking, what if like why not? Like why there is a need to not give this denomination if it is less than or equal to well, it's not always necessary that the highest number that you're choosing will give you the minimum number of coin. Okay, so for example, let's say we have denomination like 3, 4, 5 and 1. Okay, and we want to find for val equal to 7. Now in order to find for val equal to 7, and if this is your very highest denomination and it is less than equal to val, then it's not necessary that you will give a coin of 5. Why? Because in case if you give a coin of 5, then you need to give 2 coins of 1. In this case, you're giving 3 coins. Whereas if you just pass this, like you say, no, I won't give a coin of 5, I'll give a coin of 4. So in case if you give a coin of 4 and a coin of 3, then you have to give just 2 coins. So okay, I'll just rub this large eraser. Yeah. So in case, okay, we'll just use stroke eraser. So now you understood that there will be 2 possible conditions, that either we will include it or we won't. Now it is also not necessary that once you have included it, then you cannot take more than 1 coin. Suppose someone asks you for a change of 10 rupees coin. 10 rupees and you have a infinite supply of any denomination. So for the same denomination you will be willing to give 2 coins of 5 rupees, right? 5 plus 5, 10, and you will get your minimum. So for that scenario, what happened is, once we have given a coin, we'll reduce the value that he was asking and we'll ask again that whether we should take the highest coin or not. Okay, so I'll write both the condition. So one condition will be to include, so to include or to give a change. So I'll represent include with I, and in this case we'll go to I. Why I? As I told you, for 10 rupees, if we are giving 5, then we'll reduce the value of well and we'll again check if we can give that particular denomination or not. Okay. And the other condition will be that we will not include this particular coin and will move ahead. In that scenario, we'll go to I minus 1. Okay, and we'll find minimum of these 2. Okay, simple. This is a selection diagram. Now the next step is to convert this selection diagram into a recurrence relation. देखो प्रोसीजर जो है ना वो बिल्कुल सेम है, जो अपन ने 0-1 नैपसैक के अंदर से जो क्लास 1 में अपन फॉलो कर रहे हैं, अपन वही फॉलो करते आएंगे दोस्तों, ठीक है? तो सेम वही करना है. नाउ वी नीड टू कन्वर्ट दिस सिलेक्शन डायग्राम इनटू अ रिकरेंस रिलेशन. सो लेट्स लुक एट अ selection diagram. A of I less than equal to well. Okay, so we'll write a function f. Now we need to write parameters which are changing. So recurrence relation is nothing, a mathematical sequence which recursively call itself. वो देखा था ना 10th class में, उससे पहले, that we used to have this fx in which x used to change the variable x. Similarly, we need to define the variable which are changing. So one value is definitely I as it's moving from right to left, and another value is well. When we are going to include it, as I said, we will reduce the value of well and we'll see that the next coin or the same coin, can we give the denomination of the same coin again or not. ठीक है, तो एक तो हो गया अपना I और दूसरा हो गया एक well. Okay, so we'll write. Now let's see. The very first condition, if this is false, then we'll go to I minus 1. So I'll write f of I minus 1 well, because you haven't given any coin. So when this will happen, if A of I is greater than well. Okay, now let's look at a diagram. So we need to find minimum of these two when this condition is being satisfied. Okay, so let's write it. So we want min, or I'll do one thing, let's erase this. Yeah, so we'll write here min. Now min of two conditions. So either will include one coin of this denomination. In this case, we'll go to I, and what will we do? The value will be subtracted from the denomination of this coin plus one coin. क्योंकि एक कॉइन तो दे दिया है ना, तो नंबर ऑफ कॉइन्स तो पड़ेंगे यहाँ पे, तो प्लस वन कॉइन. एंड नेक्स्ट विल बी इफ वी आर नॉट including the denomination of this coin and we are moving ahead. ठीक है, that's it. So ये कब होगा? ये कंडीशन होगी if a of I is less than equal to well. ठीक है, simple. Okay, next thing is once we have written our recurrence relation, then we want to write our recursion function. ठीक है, so we'll start writing a recursion function.
तो दोस्तों, you know the basic structure of recursive function. First we have to write a base condition, then a recurrence relation or a selection diagram, and then finally we have to return the answer. Okay, so let's look at the parameter. So I basically denote the ith denomination right now we are looking into. Now well represents the value that you want to change, and a represents a is basically an array of coins, so which has the what are the denominations of the n coins that you have. So initial value of I will be n because we'll pass the number of coins. Okay, let's say not n, we'll pass n minus 1. Okay, why? Because we will use zero based indexing. Okay, cool. Chalo. So the first thing we need to write base condition. So what is base condition? Basically we want to halt a recursion function. So what we should do, think of the possibility when our function should stop. So एक तो बहुत सिंपल सी हो गई कि what if they ask for a change of 0 rupees or $0 whatever, then what you will do? Well, obviously in order to find the minimum number of coins for 0, that will be 0. So this will be our first condition. Well equal 0, then we'll return 0. Acha, what if they ask you for some change and you don't have money? How many coins you think that you should give? Like infinite भी दोगे ना तो भी कम पड़ जाएंगे. ठीक है, so we'll do one thing. अब infinite का तो कुछ हो नहीं सकता. So in case if I is less than 0, so what we will return? We'll return int max minus 1. अच्छा -1 क्यों कर रहा हूँ मैं? चलो बताता हूँ, एक मिनट रुको. Okay, so this is a base condition. The next thing we need to do is to write a recurrence relation or selection diagram. ठीक है. So what was the first condition in selection diagram? Well, if we know that the denomination value of any particular, the ith coin that right now we are looking, if that is less than equal to the value, then we have two options. So what are those two options? Well, we want to find the minimum number of coins. The one option is either we can give the one coin of this denomination. In that case, I'll just simply call our function coin and I'll pass the value I. Now maybe we want to give one more coin of this denomination, right? Okay, but the value will be decreased by the value of this coin, so that I'll write as I. Okay, and we'll just simply pass our A. Okay, now what is the next thing? Well, the other condition, oh wait. So now if you're subtracting the value, that means you're giving one coin, so you need to write plus 1. So I'll just write simply plus 1. Okay, so the other condition that we don't want to give any coin of this denomination, well, in that case we'll simply pass well and our A. Okay, so that's it. Now what if the value or the denomination that right now we are looking is greater than the change they are asking? अरे भाई, कोई तुमसे 200 रुपए का चेंज मांगा, तुम्हारे पास 500 रुपए का नोट दोगे क्या? Obviously नहीं. You will look for another denomination. So exactly that's what we are going to do. So coin, I, well and A. Did I miss something? Yes, I did. We need to go to the next denomination. So did I miss something here? Yes, I missed something here also. It's I minus 1. because we are done with this denomination and we are looking into another denomination. Simple. हो गया, बस इतना सही है और कुछ नहीं है, खत्म. चलो आगे बढ़ते हैं.
Okay, so now the problem, there is some problem here. Okay, so what happens is, like, if you guys are going to, let's say if you are trying to draw a recursion tree for the code that we have done, then you'll see that for some input we are doing, the calculation is being redundant there. I mean, we are recalculating the same thing over and over. So in order to avoid that thing, what we can do, once we are calculating something, we can store it, and storing such result is called as memoization. So we have drawn a lot of like recursion diagram already in the class 1. So I guess you guys are used to it. So recursion tree A2112 and B equal to 6. Okay, we don't need this. So if you want something, then take a denomination of some particular multiple, let's say 3, 6, 9 something, and then try to draw a recursion diagram. There you will see that for any of those values, there are some calculations which are being, which are being calculated again and again. So we are going to store that particular values, and we will avoid recalculation, and this is called as our memoization. Okay, so let's do memoization, dosto.
Okay, now if we want to do memoization, then it just needs two simple steps. The very first one is to store the values. Okay, let's store it. Achha, but wait, before storing, we need to define an array. So what dimension should I take? Well, when you want to find the dimension of the array, now that particular array is going to store the state of this recursive function. Now in order to store the state of any recursive function, you need to find dynamic parameters. So what are dynamic parameters? The parameters which changes when you call a recursive function. Now as you can see, our I and well are the dynamic parameters here. So there are two dynamic parameters, hence we will take a 2D DP. So I'll just make a global 2D DP, and I will suggest you to initialize it to -1. Okay, cool. Now the very first thing is to store the result. Now if you want to store the result, then just simply before calling the another recursive function or whatever the answer you are getting that you are returning, so before returning it, just store it in our DP array. So I'll just write I and well here. Similarly, I'll store, oops, what happened? Control Z. Okay, copy. Yeah. So we'll simply paste it here. And the next thing that we want to do is, yeah, so we have stored it. Now, what if we are, doing the same calculation and we don't want to perform that calculation again? So what we will do, we'll check if we have already calculated that particular state of recursive function. So if I and well is not equal to -1, it's not equal to -1, then we'll return TP of I well. That's it. So we have done a memoization. Ekdam simple.
Okay, dosto. So we have done the memoization. Now the next thing that we want to do is to understand something. Like, we had made our function efficient. Okay, we are not doing the same calculation again and again. But you know what? We can still do something better. We can save memory. How? Well, basically, when we do a recursive function or when we write a recursive function, then what happens is, when the recursive function is called, it occupies some space in the stack. And when does that thing happen? No, usually for a large input, we get an error of stack overflow. ठीक है? तो in order to avoid stack overflow का जो error होता है अपना, so what we do, we go from recursion to an iterative solution. तो यहाँ से पता पड़ता है कि कैसे लोग, वो जो तुम्हारे फ्रेंड्स लोग सब आते हैं और बस टेबल बनाना शुरू करते हैं ना, वो डायरेक्टली इटरेटिव पे जंप करते हैं. बट दैट्स नॉट हाउ यू सपोज टू डू इट. If you always follow the from all the way from recursion then to memoization and then to iterative, then I can assure you that you want, whenever you will get a question which is like, out of box, or when you're giving any exam, then you won't be like कि यार इसमें क्या करूं यार, इसमें कैसे होगा, तो वो चीजें तुम्हें नहीं मिलेगी, ठीक है. तो उसको अवॉइड करने के लिए ये जो स्टेप्स है उनको फॉलो करो. मैं तुम्हें अश्योर करता हूं कि तुम्हारे 80 से 90% जो क्वेश्चंस होते हैं ना वो तुम्हारे ऐसे ही हो जाएंगे, लाइक आंख बंद करके हो जाएंगे तुम्हारे, ठीक है. चलो उससे पहले एक और चीज क्लियर कर देता हूं, लाइक एक बार अपन ना विजुअलाइज करते हैं कि कैसे वो दिखते हैं. आई मीन लाइक वो टेबल जो भरती है, सो देयर इज यूजुअली वो रट्टे तोते वाली बात जो होती है ना, जैसा अपना 3 इडियट्स का चतुर करता था. So in that we have to follow all the way up from this row to go from this, then this, then this, and finally we get our answer here. क्यों भाई, किसने बोला तुमको ऐसे करने को? कौन बोला कि इन सबको सॉल्व करने से ये वाला आंसर मिलेगा? ऐसा होता है इसलिए मान लिया तुम लोगों ने. So we'll do one thing, we'll try to visualize this graphically, ठीक है. तो एक फीलिंग आएगी तुम्हें डायनामिक प्रोग्रामिंग की. So let's do it. Let's see the directed acyclic graph representation of our minimum number of coin. ठीक है? So you know, just like what we have in 2D geometry, our x and y coordinates. So we have a x axis here. Sorry, and y axis here. So this is our 4th quadrant, and if we have to represent any point, we write x comma y. So similarly, what we are doing here is in this represents the value or the change that we want to find, and this is the denomination of the coins. So your first coin has a denomination of 1, second coin has a denomination of 2, and third coin has a denomination of 3. So all these denominations are available, and someone asked you for a change of 5. So this is what you want to find. Now in order to calculate this thing, what do you need? So in order to do this, you can do one thing. So here you can take 2 steps. Either you'll say that, you know, since the value of the coin is less than the value of the change that they are asking, so we can either give the coin of this denomination or we will not give. ठीक है, as that we have seen, like अपना जो recursion diagram में अपन ने देखा 2 option थे अपने पास. So in case if I give the value, then 5 minus 3, which is equal to 2. So I'll go all the way up from there to this point. So which will be 2 comma 3. Or if I decide to not give, then I'll go from, I mean, I still have to give a change of 5, but I'm left with only 2 denomination. Okay. So I've already drawn this for you. Okay. Now there's one thing that you need to understand is that when you're going from this point to here, so you're including 1 coin, whereas here you aren't including any coin. So the weight of this edge will be 1, whereas the weight of this edge will be 0. Okay, so we'll follow the similarly for like even this point. Now we are going to calculate that either we can go, okay, here we don't have any option because we want a change of 2 and the denomination of the coin is 3, so which is greater than the 2. So as we know in our recursion diagram, if it is greater than 2, then what we will do? Well, we won't include it, we'll just move to the next denomination, and the next denomination is 2 here. So we'll move to this point, weight of the edge will be 0, here it is 1, here it is 0, here it is 1. Okay. So similarly, if you just go up, then you won't get any change, you haven't given any coin, so the change value will remain the 5 and you will left with 1 denomination. So आसान शब्दों में बोलूं, in order to calculate this, you need to calculate first this and this. Now in order to calculate this, you need to calculate first this. Similarly, in order to calculate this first, so either this or you can go from this point to here. So here you will have 0 comma 2, so 1. You have to calculate these and these 2 points. So if you keep drawing it, then you will see that all these points similarly, so here you have already got the change, so no need. Now here you will have a weight edge of 0, and then for the same 2 comma 1 denomination, so you can do that, or you can give 1 coin and you can come from there to here. So that will be 2 minus 1, which is 1, and the coin left, I mean the denomination that you're looking is 1. Similarly here, so change left will be, the change that you have to give will be 0, and you're on the first denomination. So here you will have two options, either this or you won't give and you will move to the next denomination, that is no denomination. So you're still left with 1 with 0. So basically point बता देता हूँ, ये सब diagram तुम बना सकते हो. So what you will see is this: in order to calculate this, you need to calculate first these two. Then in order to calculate this, you need to first calculate this. In order to calculate this, you need to calculate first these 2 points. Similarly, in order to calculate this point, you need to calculate first these 2 points. These 2 points. So what you are going to see is that these are the first points which need to be calculated. Then these are the next point which need to be calculated. Similarly, these are the next point, and finally we'll get our answer. And that's how we make a table and solve all those things. Okay? So I hope you guys understood like why we have to do or draw a table in the fashion we do, or I hope you guys are able to visualize dynamic programming now. Okay, so let's code it iteratively now.
Okay, now before starting our iterative solution, I just forgot to tell you one thing. I said 1 minute, 1 minute मैं बताता हूँ कि अपन ने int max minus 1 क्यों करा और फिर मैं भूल ही गया. चलो अब बता देता हूँ कि int max minus 1 क्यों करा अपन ने. So क्या है ना friends, what happens is when we are calling the function from here, so what if it return an int max value? Now in case if it return int max value and you do +1, then there is a possibility, I mean there is no possibility, I mean what will happen was like once you increment one number in int max, then it becomes int min, right? तो वो काफी negative number बन जाता है, and when you're trying to find the minimum between a positive and a very big negative number, then definitely it's going to give you answer as a negative number. So we don't want that, because we are doing +1 here. So that's why when we were doing our recursion function, we did int max minus 1. Okay, now that thing is clear. So let's come back to our iterative solution. So what I have done, I have taken the input. So I have taken the already input, and I'll just let you know. So sense denote the change that you want to find, and your n denotes basically the number of coins, and we are going to store the denomination of all those coins into the array A. And here I'm taking a DP to store the DP, a two-dimensional array to store the what? अरे जो वापस recalculate नहीं करना पड़े इसलिए to store the sub problems answers. Okay, so we'll start. Okay, so we see that in directed acyclic graph we need to start from int I equal to 0 and I less than equal to n and I plus plus. So we are going to iterate over all the coins. Okay, and we also know that the second loop that we need to take is basically the column, so which was the sense that we want to find change for. Okay, so I'll just write sense and j plus plus. Okay, so it's very simple to now to convert our recursion into an iterative solution. Okay, so what is there? Like first we will write a base condition. So base condition was val equal 0. So sense is our val and it is being represented by j. So I'll just write if j equal 0, then dp of I j equals to 0. Okay, so I'll just write 0 here. Now next thing is else if. So here we were using a zero based indexing. As I told you that initial value of I will be n minus 1. So that's why I said I less than 0. But that is not important. तुम वेरिएबल को वैल्यू के हिसाब से मत सोचो, जो कंडीशन बनानी है ना उसके हिसाब से सोचो, ठीक है. So what was the point? Why what we wanted to do here? So we wanted to tell that if we run out of all the denominations, okay, so that's what it means. And the same thing here is being represented by I equal to 0. So I equal to 0 denotes that we don't have any we don't have any coins of any denomination. Okay? So I'll just simply write if I equals 0, then dp of, अरे मतलब मैंने लेस देन 0 नहीं करा, इक्वल इक्वल 0 करा, इसलिए वो चीज समझाई. ठीक है. अच्छा, so dp of ij equals to int max minus 1. As it is, same चीज अपने को करनी है. Else if, what was the next thing? The next thing is if a of I is less than equal to well. So I'll write the same thing here. A of, now since we're using one based indexing, I'll write I minus 1 is less than equal to well, now which is being represented by j, and dp of ij is equal to min of, so either we are including this coin. Now if we are including this coin, then we may look into our same row. Okay, so I'll just write j minus a, I minus 1. Obviously we have to subtract the value of the cents, which is a j, and we need to add one coin to it. Fair enough. Okay, now what is the other condition? The other condition is to not look this coin and just look like go to the next denomination. So I'll just write I minus 1 and j. Okay, we are done here. And the final condition was else. So I hope it's visible to you. Yes, it is. Obviously it's visible क्योंकि अपन screen recording कर रहे हैं. ठीक है. So ij is equal to dp of I minus 1 j. कुछ नहीं करा, जो यहाँ मैंने लिखा हुआ था ना रिकर्शन में, उसी को सेम कॉपी पेस्ट करा. इंस्टेड ऑफ कॉइन आई एम जस्ट यूजिंग dp because we have already stored all the states of our recursive function and into 2D 2-dimensional array, and we have named it as dp. ठीक है, सेम चीज है. I minus 1 j, I minus 1 well. Okay, cool. Now final thing is we need to print our answer. So as usual answer कहाँ पे होगा? अच्छा, इसमें एक चीज बता देता हूँ. There is a possibility that obviously your answer will be in dp of n coins and whatever the signs that you have. You know, basically जो भी तुम्हें बोला गया जिसका change निकालने के लिए. अच्छा, but there is a possibility, you know, कि we don't have any denomination and we are asking for some coin. So in that scenario we need to check it shouldn't equal to int max minus 1. If that is the case, then we know that no change is possible. Okay, and okay, else we'll just see out our dp and cents. सिंपल. अरे बहुत सिंपल होता है, मैं तुम्हें बोलता ही हूँ. ठीक है, चलो ये भी खत्म.
Okay दोस्तों, so we are done here and now if you guys have liked the video then hit the like button. अगर इस क्लास से रिलेटेड जो तुम्हें और क्वेश्चंस करने हैं तो तुम्हें मेरे चैनल पे मिल जाएंगे, जिसका अपने लिंक जो है वो डिस्क्रिप्शन के अंदर है. ठीक है, मैं वहां पे तुम्हें जो भी तुम्हारे डाउट्स होंगे वहां पे मैं सारे डाउट्स तुम्हारे क्लियर कर दूंगा. तुम कमेंट्स के अंदर मुझसे अपने डाउट्स पूछ सकते हो. तो अगर अच्छा लगा हो तो अपने फ्रेंड्स, अपने जूनियर्स, उन सब के साथ शेयर करना और अपने सब्सक्राइब करना चैनल को, बेल आइकन को अपने क्लिक करना. सो मिलते हैं अगले वीडियो में दोस्तों. ठीक है, बाय दोस्तों.